When we want to assess how well the relationship between two variables can be represented by a straight line, Pearson's correlation coefficient is used. It's a statistical measure indicating both the strength and the direction of the linear relationship between two continuous variables. The direction of the correlation is positive when the two variables move in the same direction, and negative when they move in opposite directions. The strength of the correlation classified as strong, moderate, or weak depends on how well the data values cluster around a straight line. The value of the Pearson correlation coefficient are interpreted based on its sign and magnitude. While the interpretation of strength may vary depending on the field of study, this table shows a generally accepted guideline for interpreting the magnitude of the correlation coefficient. When analyzing data using Pearson's correlation coefficient, the data must satisfy certain statistical assumptions. First, both variables should be continuous, measured on either an interval or ratio scale where the data values are numbers with equal intervals between them. Pearson's correlation is inappropriate for other data types like nominal and ordinal data. Second, it is assumed that the relationship between the two variables is approximately linear. A nonlinear relationship can sometimes still show a correlation with Pearson's linear coefficient, but it may not fully represent the association. In such cases, data transformations may be applied before calculating Pearson's correlation, or a different correlation measure might be more appropriate. Third, the data must consist of paired observations. For each value of one variable, there must be a corresponding value of the second variable. Finally, the data should not contain large outliers, as even a single outlier can heavily influence the Pearson correlation coefficient and lead to misleading conclusions. For a population with two random variables x and y, Pearson's correlation coefficient is defined as the covariance between x and y divided by the product of their individual standard deviations, which is essentially a standardized or normalized form of covariance. Covariance measures the degree to which two variables change together. For a population of size n, it is calculated as the average of the product of the deviations of each variable from their respective population means. This term is known as the cross product of deviations for each observation I. The sign of the covariance indicates the direction of the linear relationship between the variables. A positive sign suggests they tend to increase or decrease together, while a negative sign suggests one tends to increase as the other decreases. Dividing the covariance by the product of the population standard deviation standardizes the measure, resulting in the unitless Pearson correlation coefficient, which ranges from -1 to +1. This standardization allows for the comparison of the strength of linear relationships between different pairs of variables. By expanding the sums of squared deviations and cross products, this is the simplified version of the population correlation coefficient formula. Now, considering a sample, Pearson's correlation coefficient is denoted by R and is referred to as the sample correlation coefficient. This is the formula for a sample of n pairs of observations. For instance, in cities with a higher number of hot dog stands, there's also a tendency to have higher crime rates. This does not mean the number of hot dog stands causes the increase in crimes. A high correlation coefficient only indicates that the data values closely follow a straight line pattern. It's important to remember that even unrelated variables can sometimes exhibit a correlation. If you like to test your knowledge on this topic, check out the link in the description below or visit our community page.